The main idea is pretty straightforward, but I want to write down the theory now before we start. First of all, what is the definition of extrema? Right. So these are usually the maximum and minimum points. So number one, f of c is the minimum of f on I when f of c is less than or equal to f of x for all x in I. Okay. So basically, in plain English, it's just saying for all x, the specific point c, when I plug it in, is smaller than all the x's I could ever plug in. So that's the definition of minimum, a minimum extrema. Now the opposite for f of c, or maximum. F of c is the maximum when f of c is greater than or equal to f of x for all x in I. Just a quick note. The minimum or maximum of a function on an interval is sometimes called, or also called, I should say, it's more appropriate, also called absolute maximum or absolute minimum or global max slash minimum. So not shorten it up there. So you'll see that in the book and in the homework. If they say find the global max or the absolute max, that means the literal highest point of the function. Okay. All right. So let me show you some pictures here. If this thing will let me. a lot of issues using the computer in the classroom. I don't know why. Can you see this, the figure?
Yes.
Okay. So let's zoom in a bit if I can. Let me. Okay. There we go. We can still see this, right? So they have a parabola that they cut off, right? So this means it's closed. So it's not going on forever. They kind of locked it off, which is kind of required to find both maximum minimum, unless you have a really weird function. But if it went on forever, there wouldn't be a max. You see what I'm saying? It would go forever, so it'd be infinity. But if you close it, you have a maximum at this highest point, which happens at 2, but the actual functional value is 5. The minimum is down here, it's the lowest point at 0, which is actually 1. So in this case, the global max is this guy, global minimum or absolute minimum. It's right there. Over here, there's a hole, so it's considered to be open. So when it's open, you can't guarantee both of a max and minimum. It has to be closed. So there's a theorem I'll write down in a second that says if a function is closed off, then you're guaranteed a minimum and a maximum. Okay. All right. One moment. It's called the extreme value theorem. Theorem 4.1 says if f is continuous on a closed interval, we'll say A to B, I guess, then f has both a minimum and a maximum. So that's what I'm saying. If it's closed off, you're guaranteed to have both. It's in plain English. Okay. I was talking about the main thing we're going to be using, huh? One of the main parts. The definition of a critical number. So let f be defined at C if f prime at C is equal to 0, or if f prime is not differentiable at C, then C is a critical number. So it's in plain English. if your C makes the derivative 0, if you plug it into the derivative and you get a 0, then it's a critical number. Or if you take a derivative and then you're not able to plug it in because it's not differentiable, but you were able to plug it in F, because F, it was a finite F, but not F prime, then it's a critical number. And we're going to use those numbers to find the max and minimums. That's going to be the main thing we're going to use to find the critical values. With theorem 4.2, so if F has a relative minimum or relative max at x equal to c, then c is a critical number. Of F. So basically what we're saying there is if there's a minimum or a maximum at C, at some number C, then C is going to be a critical number. So you can find the critical numbers in order to find the relative minimums or maximums. Okay. It seems about all the theory we really need. But let me give you some guidelines and then we'll start doing problems. Oh, wait a minute. Just a moment. All right. You guys cool on this page?
Yes.
Here are the guidelines that I'm going to be using, or in case you forget, on how to find the max or minimums. Guidelines for finding extrema, which is the same, another word for max or minimums, on a closed interval. So number one, first thing you do is find the critical numbers of F in AB. So find all the critical numbers between the interval A to B. Number two, evaluate F at each critical number in A to B. Number three, then you check the endpoints because sometimes those are max or minimums. So evaluate F at each endpoint of this interval A to B. Number four, the least of these values is the minimum, and the greatest, of course, is the maximum. All right. So let me start doing some homework problems. I'll let you write this for just a moment. Okay. This is example 1 in your homework. Let's see if there's anything worth deleting here. They're all about the same. So this is example 1, problem 1 from your homework. Well, actually, that question is kind of dumb. 1 second. Okay, let's look at number 4, and then we'll do 5. That'll be better. I can share my screen. Things won't agree with me. One moment. Okay, can you guys see this? All right, so remember what we said, right? Critical numbers are maximums or minimums, but they have to be closed. See how there's a holes here? So right away, those are not going to be extrema. This one is going to be a minimum for sure. It looks like it's going to be the global minimum or absolute minimum. These are the peaks. These are going to be relative maximums. They're about the same. So we have a maximum at 1, right? And a maximum at 3. So these are the critical numbers. All the critical numbers here are 1 because it's a value that gives you a peak, a value that gives you a valley, a value that gives you another peak. So 1, 2, and 3. That's why they chose the critical numbers. Remember, we wrote down the theorem that said that at all relative extrema, where f of x is equal to c, those c numbers are going to be critical numbers. So then they ask you, what is the maximum, minimum? So relative means, just list all the peaks, not the highest one, just all of them. So there's 2 peaks here, right? So there's one out. So it's asking you, where does it happen? So list the critical numbers at which each phenomenon occurs. So tell it which x values creates the maximum. So at 1, we get this peak here. At 3, we get another one. So 1 and 3 are the answers. Where is the relative minimum? Well, there's only one of them, so it's going to be at 2. Absolute maximum. So the highest points, there's 2 highest points. So it's going to be 1 and 3. So those are the biggest it ever gets. Absolute minimum is the smallest it ever gets. So there's only 1. So that's why we chose this guy. So once you find the critical numbers, or if you have a graph, it should be pretty easy to find out what the critical numbers are doing, whether it's a minimum or a maximum. Okay. So let's do number 5 together. But that was 4, just kind of thinking our way through it, the ideas. Number 5 says, find the critical numbers of the functions. Okay. So the way you find them is to first take the derivative. So step 1, find f prime, right?
Sir, is your screen frozen?
I don't know.
It keeps freezing a lot.
Oh, okay. I was just making sure like it wasn't my computer, but it's frozen right now.
Yeah, it's been freezing a lot.
Yeah, I'm in the classroom. It's having a lot of issues in here. 1 second. If you want to give me a few minutes, I'll go to my office instead because this classroom, I'm having a lot of problems with it.
Okay, thank you.
Give me a few minutes and I'll restart the Zoom.